today we're back to graphing, but we're going to graph linear inequalities rather than equations. So the first thing of our notes is what a linear inequality is. So it's a graph that's like an equation, or I should say a linear equation. But uses an inequality. This is going to be a less than, a greater than equal to, or less than equal to instead of equals. A solution to an equation is one answer. A solution to a linear inequality is a collection of points that make the inequality true. So we'll have a ton of different answers that we can have with a linear inequality. So the first one, we're just going to see which ones make this true. It's by substituting our x and y into the equation. So remember, the first value is x, the second value is y. 2 times 2 minus 3 times 5. And I want to see, is that less than 15? So I get 4 minus 15. And that's negative 11. So that is true, which means it's a solution. If I look at my next one, same idea. I just substituted the negative 1 and the negative 7 in. So 2 times negative 1, because that's my x value, minus 3 times negative 7. So I'm going to figure all this out first. So I get negative 2 plus 21, which ends up being 19. So I want to see, is 19 less than 15? That is false. So that's not going to be one of my solutions. So go ahead and try the other two, same method. When we graph the linear inequalities, the first thing we want to do is put it into slope-intercept form, just like we would with an equation. Remember, that is y equals mx plus b. And it may have been a while since you've looked with inequalities, but whenever we divide or multiply by a negative number, we have to switch that. We have to flip our inequality. And if you're not sure why, pick two numbers, multiply them both by a negative number, and see kind of how that sign would flip. So we are going to use a dotted. And our dotted line could look like this. Sometimes you accidentally draw a solid line and go, oops, I needed it to be dotted. Feel free to do that kind of a thing. That, to me, that also means a dotted. We use that for this symbol or this symbol. And we use a solid line, which would be your typical graphing line, if we have the equal to bar on those. So if we're going to put our equations, we need to have our y first, because that's going to help us with shading. So if our y is first, we're going to shade above the line for greater than or greater than equal to. So we want to always make sure that we are, otherwise our equations or our shading is going to be off a little bit, and we would shade below the line for less than or less than equal to. So here's an example. This first one, I want to solve for y. So we did this with our first unit. Remember, these cancel out because our goal is to get y by itself. I divide by a negative 3. When you divide by a negative number, you have to flip your sign. I never go from an equal to bar to not an equal to bar, but I will flip it over. And this gives me negative 5 plus 2/3 x. I graph this like I would normally. I start at negative 5, up 2 over 3, up 2 over 3. This is a dotted line. That dotted line piece comes completely by this symbol. So this symbol is telling me there's no equal to bar. So that means that when I put in my line on here, I'm going to make it dotted. And then I'm going to shade. And I'm shading above the line because I have a y is greater than. If I wanted to test, I could test any point up in this area, and that should make it true. And if I'm testing a point, my favorite point to test is always going to be 0, 0 if it's a possibility. So 0 minus 0 is less than 15. That's true. That tells me that every point in there is going to be a part on there. Nothing on the line is considered a solution because I'm using a dotted line. So let me try one more, and then you'll have a few more to try. Some of them are already solved for y. I'm going to have you just go ahead and graph those because that makes it a little bit easier when they're already solved. I want to look at number 5. So the first thing I do is I minus the x from both sides. So this would be gone. I can't leave a negative y, so I need to divide by a -1. When I divide by a -1, that means I'm flipping my sign. The equal to bar is going to stay. So I start at -8, put a dot, and then that slope in front of x just says x, so it's really 1/1. So I'm putting my line here. And then it's a solid bar because it has an equal to underneath that inequality. So this bar here is the one that's telling me it's a solid line. It's a less than, so that means I am shading below. So just make sure that it's clear where it is that you're shading. Looking at number 7, x is less than or equal to -4. I go to, I'm sorry if I said x is a y. I go to -4 and it's just a solid line down here. And it wants to know less than, so we don't really have that left or right. So now we kind of think about temperature scales. Less than is going to be under the line. So everything down here would be a possible solution. I don't remember if these said, yeah, that's where all of our solutions are. We don't have to actually write any out. And the last one is greater than 7, at least the last one that I'm going to do. So you'll draw in that line. It's a dotted line. So instead of changing it, we're just going to do our cheater dotted line. I automatically assume that that's a dotted line. And then it's greater than, and again, we can't really go above and below, but think that number line and what numbers would be greater than, and it would be going in that direction. Every one of those numbers over there is true. Nothing on that line is a possible solution because it's a dotted line. So you're finishing up all your graphs, making sure that you've checked them and that you understand it before you're moving on.